Section 5.6 is on least common multiples. A multiple is a number. A multiple of a number is a product of that number and a whole number. So like multiples of 3 would be 3, 6, 9, 12, 15, 18, and so forth, because 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9. It's like counting by threes. Multiples of 4 would be 4, 8, 12, 16, 20, 24. The smallest multiple they have in common in this situation is 12. So we call this the least common multiple. It is the smallest number that both 3 and 4 can be divided into and get a whole number. So 3 will go into 12 and 4 will go into 12. So the least common multiple of 3 and 4 is 12. You can find the least common multiple in another way besides just listing all its multiples. So if you have like really big numbers, it might be hard to list all the multiples of those big numbers. So we might want to find the least common multiple by doing the prime factorization, or the bottom row of the factor tree. So the least common multiple of 168 and 180 we're going to find by making the prime factorization, or the bottom row of the factor tree, and then we're going to turn around and we're going to write it with exponents. So I have 2 to the third times 3 times 7. On 180, I have 2 to the second, because there's 2 2's, 3 to the second, there's 2 3's, and a 5. So I've got the prime factorization written out using exponents, and the least common multiple is the product of the highest power of every prime number represented in the prime factorization. So like for 168 and 180, I would choose the highest power of 3, which would be 2, or the highest power of 2, which would be 2 to the third power, the highest power of 3, which would be 3 to the second, the highest power of 5, and the highest power of 7. And I would multiply all 4 of those together, and I would get 2,520. So the least common multiple of 168 and 180 is 2,520. That means that I can divide 168 into 2,520 and get a whole number, and without any remainders, and I can divide 180 into 2,520 and get a whole number and no remainder. Let's do another example here. Least common multiple of 48 and 120. So the bottom row of the factor tree would look like this: 2 times 2 times 2 times 2 times 3, or 2 to the fourth power times 3. The bottom row of the factor tree for 120 would be 2 times 2 times 2 times 3 times 5, or 2 to the third power times 3 times 5. So the highest power of 2 that I have is 2 to the fourth power. The highest power of 3 is just 3 to the first, and then I have a 5. So I'm going to multiply those 3 numbers together, and I'm going to get 240. That means you can take 48 and divide it into 240, and it comes out to be a whole number with no remainder. And I can take 120 into 240, and it comes out to be a whole number with no remainder. So 120 is the smallest number that both 48 and 120 can be divided into. Now we're going to talk about the least common denominator, and that's basically the same thing we just were doing, but you find the least common multiple of the denominators. So to find the least common denominator of 9 and 21, I'm looking for the least common multiple. So 9 is 3 squared, 21 is 3 times 7, so the least common denominator would be 3 squared times 7, or 63. So 63 is the smallest number that 9 and 21 can go into and get a whole answer with no remainder. So let's do one of these. We want to know the least common denominator of 8 and 20. So the prime factorization of 8 would be 2 to the third power. 2 times 2 times 2. The prime factorization of 20 would be 2 squared times 5, because it's 2 times 2 times 5, or 4 times 5. So to find the least common denominator, I'm going to take the highest power of 3, or 2, which is 2 to the third power, and 5. So 2 to the third power times 5 gives me 40, because this is 8 times 5. And we know that 8 can be divided into 40, and 20 can be divided into 40. Obviously, they go without a remainder, because that goes evenly with 5, and this would go evenly with 2. So we know that that works. So the least common denominator of 20 and 8 would be 40. You can also find the least common denominator when you have variables in with it. So like if I take the 36, a squared b, and I want to write the bottom row of the factor tree, I'm going to have 2 squared times 3 squared times a squared times b, because it's going to be 4 times 9, which is going to give me 36. Then if I do 27 a b squared, I'm going to have 3 to the third power times a times b squared. So the least common denominator, I'm going to take the highest power of 2, which is 2 to the second power, the highest power of 3, which is 3 to the third power, the highest power of a, which is a to the second power, the highest power of b, which is b to the second power, and I multiply them all together. So this is going to give me a 4 times a 27. Let me do it. Let's see. So 27 times 4 is going to give me 28, 108. So I have 108 a squared b squared, and that would be the least common denominator. The smallest number that can be divided into, and that can be divided into. All right, let's do another one. I'm going to find the least common denominator of these two. So I have 12 b squared, 8 ab. The bottom row of the factor tree would be 2 to the second power times 3 times b squared. This would be 2 to the third power times a times b. So I want the least common denominator, highest power of 2, highest power of 3, highest power of a, and highest power of b. So I have 2 to the third times 3 times a times b squared. So this is going to give me an 8 times 3 times a times b squared, or 24a b squared. That would be my least common denominator. Smallest denominator that both that and that can be divided into. Okay, we're going to compare fractions. In other words, I want to be able to put a greater than, less than, or equal sign between them. And there's two methods. There's one method where you find a common denominator and you compare them having the same denominator. The common denominator, or the smallest number that both 6 and 15 can go into, would be a 30. So I want to rename the 1/6 as something over 30. To get the 5 into a 30, or to get the 6 to become a 30, I would have to multiply it by 5. What I do to the bottom, I do to the top. So this fraction, 1/6, can be renamed as 5/30ths. Then I have the other fraction, and I would have to multiply 15 times 2 to have it equal 30, so I have to multiply the top times 2. So that's going to give me a 14 over 30, so obviously that is bigger. The second method is what we call a butterfly method, or a multiply up method. You multiply up, 15 times 1 is 15, 6 times 7 is 42, 42 is larger than 15, so I know I'm going to put a less than sign between it. Obviously that's a whole lot easier, but it can be done the other way. Common denominator here would be a 16, so I would have to multiply the 4 times 4 to get 16, so that means I multiply the 1 times 4. So I'm comparing 4 sixteenths and 3 sixteenths, so that is greater than that. If I multiply up, I have a 16 and I have a 12, and obviously 16 is greater than 12, so I'm going to put the inequality pointing to the 3 sixteenths. Homework on this is page 229, 17 through 41 odd, and 45 through 51 odd.